this video we're going to be talking about linear sequences and finding their nth terms. So a linear sequence is a progression of numbers that is either increasing or decreasing as it continues. So every separate component of a sequence is called a term, and the amount that they are differing by is called the common difference. So if we check out this sequence here, 3, 5, 7, 9, 11, 3 is the first term, 5 is the second term, 7 the third, 9 the fourth, 11 is the fifth term. Now this sequence would go on forever and ever and ever. It would never stop. So you can probably tell that the number that this sequence is increasing by each time is 2. Every term is increasing by 2 to get to the next term. So we would say the common difference of this sequence is 2. Now the nth term always sounds a little bit mental, to be fair. Remember, n isn't really a letter in the normal sense. N is a number. So we find this rule, or this recipe, if you like, called the nth term, that we can then use to work out any number term in the sequence that we like. So instead of having to write down 1,000 terms to find the 1,000th term, which would take forever, and it wouldn't be interesting enough for us to put all of that effort in, but instead of having to do that, we can use the nth term to find the 1,000th term. So they're very, very useful. So let's have a look at how we find it. So the first thing that we need with our sequence is we need to find the common difference. So how we're getting from one term to the next term. So carrying on with this sequence, again, our common difference is 2. So whatever the common difference is in our sequence, that number multiplies the n part of our nth term. So if our common difference is 2, then our nth term is something to do with 2n. So if we then write out the sequence 2n, remember that n is the term number of the sequence. So for the first term of 2n, we're doing 2 times 1, which gets us 2. For the second term of 2n, we do 2 times 2, which is 4. For the third term, we do 2 times 3, which is 6, and so on. So if we write out the sequence 2n, then we're going to get 2, 4, 6, 8, 10, etc., going on forever and ever and ever. Now that's quite close to our original sequence, but it's not quite the same. So now we need to work out how do we get from each term of 2n to the corresponding term in our sequence. So how do we get from 2 to 3? How do we get from 4 to 5? How do we get from 6 to 7? How do we get from 8 to 9? How do we get from 10 to 11? The answer to all of those questions is that we add 1. So our sequence is 1 more than the 2n sequence. So our nth term is 2n plus 1. Now it's quite nice maths this because it allows you to check your answer. Let's use our sequence and the nth term then to check that we're right. So for the first term of 2n plus 1, we would do 2 times 1, which is 2, add 1 is 3. Happy days, that's our first term in our sequence. For the second term, 2 times 2 is 4, add 1, happy days, it's 5 again. Let's check it for the third term. So 2 times 3 would give us 6, add 1 would give us 7. Ideal, that's our third term. So it's working, we've got the right answer. So the nth term of our sequence is 2n plus 1. Now we can use that to find some higher terms in our sequence, as I said before. So say that we wanted to find the 10th term of our sequence, then we substitute n equals 10 into the nth term. So into n plus 1, where n is equal to 10, we get 2 times 10 plus 1. Now that would give us 21. If we wanted the 100th term, then we would substitute in n equals 100. So 2 times 100 would give, the nth term when n is equal to 100 would give us 2 times 100 plus 1, and that would give us 201. Then if we want the 1000th term, we just substitute n equals 1000 into the nth term rule. So we would get 2 times 1000, add 1, and that would give us 2001. Okay, let's take a look at quite a few questions then on finding the nth term. Okay, then let's check out this bad boy. So if we want to find this nth term, the first thing we need to know is how we're getting from term to term. So here, to get from 8 to 11, we're adding 3, and it's the same all the way through because it's a linear sequence. So that tells us that our nth term is something to do with 3n. So if we write out a few terms of our sequence 3n, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 12, 15, etc. And that's going to carry on forever and ever and ever. So again, that's not our sequence. What we now need to know is how do we get from 3n to our sequence. So how do we get from 3 to 8? How do we get from 6 to 11? How do we get from 9 to 14, etc.? Now the answer is that each time, for each of those terms, we need to add 5. 3 add 5 is 8, 6 add 5 is 11, 9 add 5 is 14. So the nth term to our sequence is 3n add 5. Cracking. Okay, let's check this guy out. So again, the first thing that we need is his common difference. So for each time, we're adding 7. So that means the sequence is something to do with 7n. So if we write out the sequence 7n, 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28, 7 times 5 is 35. So now we need to work out how do we get from 7n to our sequence. So to get from 7 to 5, we would take away 2. To get from 14 to 12, we would also take away 2. To get from 21 to 19, we're going to take away 2. So our nth term is 7n minus 2. Now again, if we want to check it, let's use our sequence to check. So when n is equal to 1, for the first term, we're going to get 7 times 1, which is 7, minus 2 is going to give us 5 for our first term, as we have. When n is 2, 7 times 2 is 14, minus 2 is going to give us 12, ideal. When n is 3, 3 times 7 is 21, minus 2 is 19. Happy days, our nth term works. Okay, 5, 15, 25, 35, 45. We want to find the nth term again. So we're getting from term to term by adding 10. So that means our sequence is something to do with 10n. So if we write out the sequence 10n, 10 times 1 is 10, 10 times 2 is 20, 10 times 3, 30, 10 times 4, 40, and 10 times 5, 50. Don't forget the dot dot dot. Okay, so now we need to work out how do we get from 10n to our sequence. So we get from 10 to 5 by subtracting 5, 20 to 15 by subtracting 5, 30 to 25 by subtracting 5. So our nth term here is 10n minus 5. let's put a little bonus question in here. Let's say that we want to find the 50th term. So to find the 50th term, we're going to do 10 times 50 minus 5. 10 times 50 is 500. Minus 5 is going to give us 495. So the 50th term of this sequence is 495. Okay, let's go for this one then. So we're starting off in the negatives. Don't let that scare you. So what are we going up in? If you don't like the fact that we've got a negative first term, check out the difference between one of the other pairs of terms. So instead of thinking how do we get from -3 to 1, think about how we get from 1 to 5 or 5 to 9. So the answer you'll get is that we're adding 4 each time. So our sequence is something to do with 4n. So if we write this bad boy out, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20. Okay, so there's the sequence 4n. How do we get from 4n to our sequence? So again, if that -3 there is troubling you, just ignore its existence. So let's look at the second term of each sequence. How do we get from 8 to 1? We take away 7. The third term, how do we get from 12 to 5? We take away 7. So our nth term is 4n, take away 7. Now if we just check that with the first term, for the first term, n is equal to 1, so 4 times 1 is 4, then take away 7 will give us the -3. Let's say here that we wanted to work out the 100th term. Then we're going to get 4 times 100 minus 7. 4 times 100 is going to give us 400 minus 7, and that will give us 393. Okay, let's check out another one. Okay, on with the next one. So this time we've got a slightly different situation because our sequence here is decreasing. So this time our common difference is actually -1, because to get from 10 to 9, we -1. From 9 to 8, we -1, etc. So that means the n part of our nth term is going to be -1n, or just -n. So if we write out that sequence, we're going to get, it's just minus the normal sequence of counting numbers. So -1, -2, -3, -4, -5. Now we need to work out how do we get from -n to our sequence. So how do we get from -1 up to 10? Well, the answer is that we add 11. How do we get from -2 to 9? We also add 11. So our sequence here is going to be -n plus 11, which we can also write as, it doesn't matter at all which way around we write it, we can also write that as 11 minus n. So let's say here then that we want to work out the 20th term. Then we're going to substitute in n equals 20, so -20 will give us exactly that, -20, add 11, and that's going to give us -9. So the 20th term of that decreasing sequence is going to be -9. Okay, let's look at a couple more. So again here we've got another decreasing sequence. We're going down by 3s here. So our nth term is going to be something to do with -3n. So if we write out the sequence -3n, -3 times 1 is going to give us -3. -3 times 2, -6. -3 times 3, -9. -3 times 4, -12. And then finally, minus 15 for our fifth term. Okay, so how do we get from minus 3n to our sequence? How do we get from minus 3 to minus 2? We add 1. Minus 6 to minus 5, we add 1, etc. So our nth term here is minus 3n plus 1, which again we can write as 1 minus 3n. Again, remember, if you like, you can check your nth term. So let's check this one against our sequence. So for the first term, n is equal to 1. So if we substitute that into our nth term, we're going to get 1 minus 3 times 1. So 1 minus 3 is 2. Minus 2. Ideal, that's what we want it to be. If we check our second term, 1 minus 3 times 2 is going to give us 1 minus 6, which is going to give us minus 5. If it works for 2 terms, that's a good indicator that it's right. But let's check it for a third one. Let's check it for our third term then. So 1 minus 3 times 3, it would give us 1 minus 9, which is going to give us minus 8. Let's say we wanted to work out the 10th term. Well, we're going to have 1 minus 3 times 10, which is 1 minus 30. Now 1 minus 30 is minus 29. Job's a good one. Guys, this one's going to be the last one in our adventures in this video. So again, we've got a decreasing sequence, so we need to work out the difference. So we're going down in tens this time. So that tells us our sequence is something to do with minus 10n. So minus 10 times 1 is minus 10. Minus 10 times 2 is minus 20. Minus 10 times 3, minus 30. Minus 40. Minus 50. Etc. Okay, so now we need to work out how do we get from minus 10n to our sequence. So to get from minus 10 up to 0, we need to add 10. To get from minus 20 up to minus 10, we need to add 10. So our nth term rule is minus 10n plus 10, which again, we could also write that. It doesn't matter at all which way around you write it. We could also write that as 10 minus 10n. So let's check that against our sequence. So for our first term, we're going to get 10 minus 10 times 1, which is 10 minus 10, which is 0. For our second term, we're going to get 10 minus 10 times 2, which is 10 minus 20, which is minus 10. Let's check it works for a third term. So for the third term, we're going to get 10 minus 10 times 3, which is 10 minus 30, which is indeed going to give us that minus 20. So let's say for this one we were asked to work out the 20th term. Then I'm going to use the first form of our nth term here, this one on the left. So we're going to get minus 10 times 20 plus 10. Now minus 10 times 20 is going to give us minus 200 plus 10, and that's going to give us minus 190. Okay guys, that's an introduction to linear sequences and nth terms. Hope it's useful.